Hi dear students, welcome to Geeta's classes. In this class, we are going to find out the Laplace transform of integrals. So before that, you should be thorough with the formulas, that is the Laplace transform of elementary functions like f of t, the definition of L of f of t, and the Laplace transform of k e per at e per minus at, sin at cos at, sin h at cos h at, t per n, and first shifting theorem. That is, these are the Laplace transform of basic functions you have to be thorough with. And first shifting theorem says that if the function is multiplied by e power at, without e power at, you find the Laplace transform and replace s by s minus a. If it is multiplied by e power minus at, without e power minus at, you find the Laplace transform of this function, replace s by s plus a. Okay. All these proofs and problems we have done in the previous classes. Please go through that so that you can be thorough with the topics. And multiplication by t power n. Always remember, multiplication is always connected with differentiation and division with integration. Okay. So if the function is multiplied by t power n, without t power n you find the Laplace transform and differentiate n times with respect to s and attach one minus 1, multiply by minus 1 per n. Similarly, if it is divided by t, without division, you find the Laplace transform of f of t and integrate from s to infinity. Similarly, if it is divided by t squared, then integral s to infinity f bar of s ds. Okay. Similarly, q cube means 3 times you have to integrate and so on. So now let us, in the previous class I have explained about the Laplace transform of derivatives. F dash of t means again multiply. Always remember multiplication and derivatives or differentiation, and division integration. Okay, remember like that. So L of f dash of t is s into L of f of t minus f of 0. F double dash of t etc. L of nth dash of t is the formula. This is the formula, and please remember these formulas, and the proofs are available in the previous classes. And next, now we are going to see Laplace transform of integrals. So if you want to find out Laplace transform of integral 0 to t f of u du, then without this integration, that is f of u du, L of f of t you have to find out, then just divide it by s. Okay. So now let us see the proof. Let us take this Laplace transform of this function I want to find out. So I am going to assign one name, g of t is equal to integral 0 to t f of u du. So if you want to find out, I want to use this formula, that is g of 0, I want to find out the value. So I am going to use that. So let us find out g of 0. G of 0 is what? Integral 0 to 0 f of u du. If both upper and lower limits are same, the value will be 0. So g of 0 is 0. Now what is g dash of t? D by dt of integral 0 to t f of u du. What is this? Differentiation of integration. Both are inverse functions. So I can write this as f of t. So g dash of t is what? F of t. G of t is our integration, given integral. Okay. So g dash of t is equal to f of t. So taking Laplace transform on both sides, we get L of g dash of t is equal to L of f of t. By this, what is L of g dash of t? By differentiation of function, Laplace transform of derivatives, g dash of t. By using that formula, L of g dash of t is equal to s into L of g of t. See, L of f dash of t is what? S into L of f of t minus f of 0. In the place of s, I have g. So L of g dash of t is s into L of g of t minus g of 0. What is L of f dash of t? F bar of s. Okay. G of 0, just now we have found out g of 0 value as 0, right? So s into L of g of t minus this value will not be there. That is s into L of g of t is equal to f bar of s. Therefore, L of g of t is equal to 1 by s into f bar of s. What is L of g of t? L of, what is g of t? We have assumed to be g of t is equal to 0 to t f of u du, right? 0 to t f of u du is equal to 1 by s into f bar of s. This is what we want to prove. Now let us do some problems on this. So find Laplace transform of integral 0 to t e power minus t cos t dt. So whenever you want to find out the Laplace transform of some integral, it is just divided by, remove this integral, that's all. 1 by s into L of, without this integral, whatever function is there, you write L of e power minus t cos t dt. That is 1 by s into, what is L of e power minus t? When it is multiplied by e power at or e power minus at, you have to remember, recollect the first shifting theorem. So without this e power minus t, first let us find out L of cos t, in which s should be replaced by s plus 1. Okay, that is 1 by s into L of cos t is what? S by s squared plus 1, in which s should be replaced by s plus 1. Okay, that is equal to 1 by s into s plus 1 divided by s plus 1 the whole squared plus 1. That is equal to 1 by s into s plus 1 by s squared plus 2s plus 1 plus 1, that is 2. This is the answer. 1 by s into s plus 1 by s squared plus 2s plus 2. That is, without integration, you find the Laplace transform of the remaining integrand, that is the remaining function, and divide it by s. Okay. So let us do some more problems. L of e power minus t into integral 0 to t. So under here integrand is sin t by t. Okay, after that integral only you have to replace, you have to use e power minus t. So whenever it is multiplied by e power t or e power minus t, what you have to do? Remaining, without this e power minus t, you have to find out, that is L of integral 0 to t sin t by t dt, in which s should be replaced by s plus 1. Okay, that is L of, now integral means without this 1 by s, you have to multiply by 1 by s or divide it by s into L of remaining function, that is the integrand. So L of sin t by t, without this integral you find the Laplace transform and multiply by 1 by s or divide it by s, in which s should be replaced by s plus 1. That is 1 by s into, now if it is sin t, L of sin t by t, this I have done in the previous class, we have found out, that is division by t. Okay, one class I have explained about division problems on division by t. In that class I have explained L of sin t by t. This we have found it to be cot inverse of s plus 1. Sorry, cot inverse of s. Cot inverse of s. And in which s should be replaced by s plus 1. That is 1 by s plus 1 into cot inverse of s plus 1. Nothing, it is not difficult. Integral L of sin t by t is equal to, if you want I will explain that also little. Sin t by t means what? Integral s to infinity L of sin t ds. Okay, that is equal to L of sin t is what? Integral s to infinity 1 by s squared plus 1 into ds. So if you integrate, you will be getting tan inverse of s from s to infinity. Tan inverse of infinity minus tan inverse of s, that is pi by 2 minus tan inverse of s, which is cot inverse of s. This is what I have written directly here. L of sin t by t is cot inverse of s. Okay. And in which s should be replaced by s plus 1, because it is after that only we have multiplied L of e power minus t into. Therefore, after finding this integration, we have to replace s by s plus 1. Okay. Next question. L of t into e power minus t into sin t dt. This is equal to 1 by s into, because integral, so replace it by, without this integral find the remaining Laplace transform multiplied by 1 by s. So L of t into e power minus 2t sin t into, sorry, not dt, integration is removed. So 1 by s into, now e power minus 2t. So one second. L of e power minus 2t. So find without e power minus 2t, L of t sin t you have to find out, in which s should be replaced by s plus 2, because e power minus 2t, that is 1 by s into, what is L of t sin t? Minus d by ds of L of sin t, in which s should be replaced by s plus 2. You keep on removing one by one. 1 by s into minus d by ds of L of sin t is what? 1 by s squared plus 1, in which s should be replaced by s plus 2. That is equal to 1 by s into minus d by ds of s squared plus 1. So minus of minus 1 by s squared plus 1 the whole squared into 2s. In which s should be replaced by s plus 2. Sorry. S should be replaced by s plus 2. So here this is equal to minus minus will become plus. So 2s by s into 1 by, sorry, 1 by s into, you are not supposed to take inside, otherwise they will get cancelled. So 2s by s squared plus 1 the whole square, in which s should be replaced by s plus 2. Okay. So 1 by s into, now s should be replaced by s plus 2. So s2 into s plus 2 divided by s plus 2 the whole square plus 1 the whole square. That is equal to 2 into s plus 2 divided by 2 into, s into s squared plus 4s plus 4 plus 1. So that is 5 the whole square. So 2 into s plus 2 by s into s squared plus 4s plus 5 the whole square is our answer. Okay. So what we have done, L of integral of, so integral I have removed first. Without integral you find the remaining whatever is integrand. For this you find the Laplace transform divided by s. So 1 by s into L of t into e power minus 2t. E power minus 2t, without that you have to, first shifting theorem. So without this you find the Laplace transform, that is L of t sin t, and s should be replaced by s plus 2. And if it is multiplied by t, differentiation. So minus d by ds of L of sin t. Okay. Then we have differentiated and replaced s by s plus 2. And this one, how will you find out? Integral of 0 to t. Please remember, L of integral 0 to t f of t dt is equal to 1 by s into f bar of s. If it is L of integral 0 to t twice, integral 0 to t f of t dt dt means 1 by s squared into f bar of s. If it is triple integral, then you have to multiply by 1 by s cube. So 1 by s cube into L of t sin t. Okay. So this is equal to 1 by s cube into, twice means 1 by s squared. Here triple integral. So 1 by s cube into L of t sin. So L of t sin t is what? Minus d by ds of L of sin t. That is 1 by s cube into minus d by ds of L of sin t is 1 by s squared plus 1. That is 1 by s cube into minus of minus 1 by s squared plus 1 the whole square into 2s. minus minus will become plus, so this is equal to 1 by s cube into 2s by s squared plus 1 the whole square, right? Yeah. So 1 s will get cancelled, this will become s squared. So this is equal to 1 by s squared into 2 by s squared into s squared plus 1 the whole square. So this is the answer. So if it is triple time integral 0 to t, and please be careful about the limits also. If it is 0 to t, then t into remove that integral, and without that you find the Laplace transform divided by s. So double integral is 1 by s squared, triple integral means 1 by s cube, and so on. Okay. So please give a like for the class and share it with your friends.